In this video, we're going to take a look at evaluation of an integral, a double integral, over the region that's bounded by two curves, y equals square root of x and y equals x cubed. Okay, so we got to integrate 2xy minus y cubed. And when they say dA, that's just a short way of writing either dy dx or dx dy, kind of like you choose. So first we're going to look at it as a type 1 region, which means that dy will be inside and dx is going to be outside. So what's going on with the type 1 region? In a type 1 region, you need to have one function that's completely above the other one. Now, they can't touch, they can be equal, but they cannot switch and flip. So over a certain interval, so let's say from A to B, at the same time, the bottom function, so we'll just call it b of x to make it easier, is less than or equal to the top function for every x on that interval. Okay, now for us here, we've got y equals square root of x, and then we also have y equals x cubed. Now, they are not telling us the limits. So in order to figure out the limits, you need to set these two equal each other. So you need to figure out where is square root of x equals x cubed. So I am going to just do this by basically trial and error and trying to figure out when that happens. And because we have a square root, we're looking for a non-negative number, so we cannot have negatives. 0 would be one example right away, because square root of 0 is 0, and 0 cubed is also 0. So 0 is one solution, and you may have already guessed then the other solution is 1. So square root of 1 is the same as 1 cubed, which is also 1. So what is happening on that interval from 0 to 1? So here we got 0 to 1, here we got 0 to 1. So square root, the way that works is it's kind of like a parabola, but it's not, it's not vertical, it's like on its side, like a horizontal one, right? But a piece of it. So it'll look something like this. Okay, so that's going to be square root of x. And then x cubed for values of x between 0 and 1, that's going to be something like that. So this is going to be x cubed, and this is going to be square root of x. Okay, so then when we set it up, we need to first set up the outside limits. So the outside limits here are the x limits. So how does x change? So these are just the extreme values of x. So you can see that x changes from 0 to 1, right? And always remember that the outside limits should be numbers. They generally do not have variables in them. The inside limits, unless the region you are looking over, like over integrating, if it's a rectangle, then the inside limits are numbers. But if it's not a rectangle, there is no way both of them are numbers, because then you get a rectangle. Okay, and then if you're talking about like which variable could be inside these limits for the inside integral, it's always the outside variable. So the outside variable is x. That means that one of these limits, or maybe both of them, will have x in them. Okay, so we already know what the functions are, x cubed and square root of x, but which one is which? Okay, so which one is the bottom and which one is the top? So just imagine that you are in here. Okay, so this is you, this is your weird house, whatever. What is your floor? So your floor is x cubed, so that's going to be here. And then your ceiling or your roof or whatever is square root of x. Okay, so that we set that up, and we're going to come back to evaluating it, but now I want to also set it up as a type 2 region so we can practice. Okay, so here we got 0 to 1, and then we got x cubed to square root of x. All right, so what about type 2? So what's happening with type 2? Now I'm going to redraw the picture again, but this time I'm going to label them differently, because now what happens is now you want to know how does your y change. Because in the type 2, what should happen is for y values between some c and d, there should be clear left curve, right curve. So the left curve, let's call it L of y, is going to be less than or equal to the right curve. Okay, left is less than right. Oh, for every y on that interval. Okay, so again, I'm going to redraw the picture. So this is going to be 1 right here. And this is my square root of x, but I'm not going to label it yet. and then that's going to be x cubed. So when I set it up, what do I do? So first of all, the limits are going to be, and of course the integrand is the same, but the limits are going to be dx dy for type 2. So x is inside, y is outside. So the outside limits are the y limits now, because remember the outside integral, those are the y limits. So this is going to go from 0 to 1. What about the inside? So inside these limits, unless the region is a rectangle, must have the outside variable, possibly both, but maybe just one, but there has to be the outside variable, in other words, y. Well, we have two. We have y equals square root of x, and we have y equals x cubed. But we cannot put x cubed in square root of x because that's not the outside variable now. The outside variable is y. Okay, so what do we do then? What do we do then? Okay, so we need to solve each one for x. So here you got x equals, so we're going to square both sides. That's going to be y squared. And then we are going to take a cube root. So that's going to be cube root of x, right? So that's going to be, I'm sorry, not cube root of x, cube root of y. All right. So the square root of x became y squared. So this guy is y squared. And the x cubed became cube root. So this is going to be cube root of y. Now, when we set it up, which is the left and which is the right? So go from left to right. You're going to see that this curve right here is the left, right? And then the other one is on your right. So left, right. Okay, so what can we say here is that it's going to be left, which is y squared, and then cube root of y is going to be on the top. Okay, so that's the setup. And then you can actually verify this by evaluating both of them just to see if it's the same, because the Fubini's theorem says that they have to be equal. Okay, so now let's go ahead and compute I'm just going to do it one way. I'm not going to do both for the sake of saving some time. So here we've got dy dx. Okay, so we're going to integrate. First, we're going to integrate the inside integral. So this guy right here. So we want to integrate that with respect to y. So when you're integrating, the 2 and x is going to be just like a constant multiple that you keep. So this is going to be 2x. And remember, y to the power 1, the way you integrate that is you add 1 to the power, so that becomes y to the 2. And then you divide by the same numbers and the power, but I like to just have 1 over. Okay, so this is going to be 1/2. And then minus y cubed, that's going to become 1/4 y to the 4th. Okay, so now we want to substitute x cubed and square root of x, and we have to put for which variable. So we're going to put for y, okay? All right, so let's see what happens. Now, the 2 and 1/2 will cancel out over here, so then we get 0 to 1. And then instead of y, we are substituting the top limit, so square root of x squared, that's just x, right? Minus 1/4. So here we are raising square root of x to the power 4. So that's going to be like raising it to the power 2, which is going to give us x, and then raising it again to the power 2, which is going to give us x squared. Okay, so we got that part. Now let's substitute the bottom. So for the bottom, we got x and then x cubed to the power 2. This is the same thing as x to the power 6. And we got x cubed to the power of 4, so that's x to the power 12. Wow, we got a lot of different powers here. Okay, so we're going to simplify before we integrate. So we've got x squared minus 1/4 x squared minus x to the power 7, because remember we add powers when they're multiplied, and then it's going to be actually plus, right, because we distribute the minus 1/4 x to the power 12. So what can we simplify? What are like terms? So the like terms here are the first two. Okay, so the first two, which is 1x squared minus 1/4. So that's 3/4 x squared. And then minus x to the 7 plus 1/4 x to the 12. Okay, so now there is no other terms we can combine. So we're just going to integrate x squared. So we add 1 to the power, becomes x cubed, and then we divide. So we get 1/3 minus. So then this is x to the 8, and then 1/8 in the front, plus x to the 13, and then 1/13 in the front, and we also had 1/4. So that's there. And then we substitute 0, 1. So the good news is that it's easy to substitute 0 because that's just going to be 0. So let's go ahead and evaluate all of this stuff. So the 3 is going to cancel. And so we're just going to get 1/4 minus 1/8 plus 1/4 times 13. Okay, so it's going to be some ugly fraction. So I've got 15 divided by 104. Okay, so let's see if that is correct.